Hi. Have you ever encountered an idea so beautiful that you wanted it to be true? The ancient Greeks were fascinated by a special group of three-dimensional shapes that we now call the Platonic solids. These shapes are remarkable because every face is the same regular shape, every edge has the same length, and every corner is arranged in exactly the same way. A cube is one example. Each of its 6 faces is an identical square. Another is the tetrahedron. It's formed from 4 identical triangles. There are also shapes that are made from 8 triangles, 20 triangles, and 12 pentagons. And that is the complete list. There are exactly 5 Platonic solids. Not 6, not 100, only 5. The ancient Greeks found this deeply significant, and personally, I find it pretty cool. These shapes seem to possess a kind of mathematical perfection. Plato even connected them to the structure of the physical world. He associated 4 of the solids with what were believed at that time as the basic elements: earth, water, air, and fire. The 5th was connected to the cosmos itself. That theory was beautiful. Each fundamental part of nature had its own perfect shape. Mathematics appeared to reveal the hidden architecture of the universe. Nearly 2,000 years later, the astronomer Johannes Kepler was captivated by these same 5 shapes. At the time, only 6 planets were known, and Kepler noticed that 5 Platonic solids could be placed between 6 spheres, and he wondered whether these shapes explained the distances between the planets. He imagined one sphere representing the orbit of a planet. Inside it, he placed a Platonic solid. Then he placed another sphere inside that solid, followed by another solid, and so on. It was an extraordinarily beautiful model. But it was wrong. As measurements of the planets became more accurate, the distances did not fit Kepler's model. Now, I find Kepler's story encouraging because his mistake did not make him a poor scientist. His desire to understand the heavens eventually contributed to a much greater discovery: that the planets travel in ellipses rather than perfect circles. Kepler was willing to release a beautiful theory when reality would not support it. That can be difficult. We are drawn to explanations that feel balanced, complete, and elegant. When all the pieces fit neatly together, we experience the satisfaction of seeing a pattern. But our ability to find a pattern does not guarantee that the pattern is true. Sometimes we discover the hidden structure of reality. Other times, we impose a structure because we want reality to be simpler and more orderly than it is. Now, this does not mean beauty should make us suspicious. Beauty is often a valuable guide in mathematics, in science, and art, and faith. It awakens curiosity and invites us to look more closely. But beauty is an invitation to investigate, not permission to stop asking questions. The Platonic solids really are beautiful. Kepler's model really was imaginative, but reality was larger than the beautiful shape he had created for it. Perhaps humility means allowing reality to correct even our favorite ideas. So, here's a challenging question for you and for me. Are there ideas that we are so passionate about that our passion sometimes leads us astray? And to be honest, that is a difficult lesson that I have had to learn. Passion can inspire us to see possibilities that others miss. But if we're not careful, it can persuade us to see patterns that are not really there. Humility allows us to remain passionate while still giving reality the final word.